In this video, I would like to talk about the Simpsons rule, and then I will make a comparison between the Simpsons rule and the trapezoidal rule. So the trapezoidal rule came from the Riemann sum, the left sum and the right sum. The trapezoidal rule is the average of the left sum and the right sum. So you take the left sum plus the right sum divided by 2. So since this is a numerical integration, we must have the integral. So my integral is the integral of f of x goes from a to b, and then dx, that is approximately equal to trapezoidal rule. The t stands for trapezoidal, and then we have delta x divided by 2. Delta x is taking b minus a and then divided by n, where n is the number of subintervals. For trapezoidal rule, n can be odd or even. So where is the divided by 2? The 2 in the denominator came from. Trapezoidal is the average of the left sum and the right sum. So we take the left sum plus the right sum divided by 2. So where we divided by 2, that's how we get the 2 in the denominator. And then for trapezoidal rule, we go from x of 0, so the very first x value, all the way to the very last x value. And then the coefficient pattern is starts with 1, ends with 1, and then in the between the start at the end, we use all 2. So start at 1, ends at 1, and then a bunch of 2 in the middle. For trapezoidal, the number of subintervals can be odd or even. So what is the delta x represent? You might say, all right, the delta x represent what? The delta x represents the base of the rectangle. Still remember the Riemann sum. So what is Riemann sum? We have a curve. I am trying to approximate the area under the curve using many rectangles. And then the base of the rectangle is delta x. And then what about the f of x0, f of x1, f of x2? That is the height of the rectangle. So when you take the delta x times the y value, because f of x0 is a y value, right? The f of x0, so that is a y value. When you take the base times the y value, that means you are taking the base times height, then you get the area of one rectangle. When you take the delta x times f of x1, then you have the base times height, then you get the area of the next rectangle. So these are all in the Riemann sum. We talk about all this before we talk about integration. And then for Simpsons rule, the biggest difference between Simpsons and trapezoidal is Simpsons rule, the n, the number of subinterval, must be even. If n is odd, then we cannot use Simpsons rule. So let's take a look at the difference. For Simpsons rule, we have delta x divided by 3. The divided by 3 came from the proof of the Simpsons rule. Since the proof is relatively complicated, we are not going to talk about the proof in this video. So the difference between trapezoidal and Simpsons, the very first difference is delta x divided by 3, not divided by 2. And then look at the coefficient pattern. We have start at 1, ends at 1, and then the rest we have 4, 2, 4, 2, 4, 2, 4, 2, and that must be ends at 4. So the coefficient pattern between Simpson and trapezoidal is trapezoidal starts at 1, ends at 1, a bunch of 2 in the middle. For Simpson, starts at 1, ends at 1, but in the middle we have 4, 2, 4, 2, 4, 2, 4, 2, and this pattern must end at 4. When n is even, the pattern will end at 4. So the 4, 2, 4, 2 pattern ends at 4. This is a must. It's not optional. Okay? When n is even, yes, it will end at 4. You don't need to worry about it. So regarding the n is even and n is odd, allow me to give you a couple examples for the Simpsons rule. So the first one is when n is equals to 6. So when n is equals to 6, I have S6. So that's S stands for Simpson, and delta x divided by 3. So for n equals to 6, there are 6 subintervals, right? And then we have f of x0, x1, x2, x3, x4, x5. Do you see that? What's the problem in here? What's the problem in this calculation? I have f of 0 and then I went all the way to x5, but is this correct? The answer is no. Do you see that there are 2 missing coefficients? So if you If you put the coefficients down, then that will be 4, 2. And then the last one must be a 1. What's the problem? The problem is the pattern must end at 4. So if you go from x of 0 to x of 5, then this is what you're thinking. All right, from 0 to 5, there are 6 numbers, right? So since n is equals to 6, then we use 6 y values. So what's wrong with it? So think about this. If you go from 0 to 5, yes, there are 6 numbers. But 6 numbers, listen, 6 numbers is not enough to build 6 intervals. Look at my number line. In my number line, I went from 0 all the way to 6. But then you are going to ask me a question. Hey, 0 to 6 are 7 numbers, not 6 numbers. You say n equals to 6, but you put 7 numbers on your number line. So what's going on? Take a look. From 0, 1, 2, 3, 4, 5, 6. So I have one line. I use 7 numbers to build 6 intervals. Again, I have to use 7 numbers to build 6 intervals. I know 7 is odd, but I need 7 numbers to build 6 intervals. I don't care how many numbers you use. I want even numbers of subintervals. So n is equals to 6. That is provided by the problem. In order to build 6 intervals, you have to use 7 numbers. So now let's fix the expression. So to fix the expression, I ends at 5, but that is insufficient, so I have to erase that. So we have to go all the way to x of 6, right? So let's write this down. After x of 4, so we have to plus f of x5, and then we have f of x6. So because we need 7 numbers to build 6 subintervals, and then what is the coefficient pattern? Again, the last number must be 1. So if you go like this, 1 ends with a 1, and then 4, 2, 4, 2, and now you have a 4 for the f of x5. All right, so you need 7 numbers to build 6 interval. This is an example where f of x, you start at x0. What if you start at f of x1? So that will be the next example. Let's take a look. So the next example, you start at f of x1. So this time again, you want 6 subintervals. I need 7 numbers to do so. So that's why in my number line, I go from 1 all the way to 7. The previous line, I go from 0 to 6. 1 to 7, you have 7 numbers, right? So 7 number is enough to build 6 intervals. And then in my expression, I went from x1 all the way to x7. And then take a look at the coefficient pattern. Starts at 1, ends at 1, and then 4, 2, 4, 2, 4. 4 for the f of x6. So now this ends at the pattern ends at 4. Starts at 1, ends at 1, and then 4, 2, 4, 2, 4. Okay, 7 numbers to build 6 intervals. So now, what if n is odd? So the next example is, what if n is odd? So n is odd, so this one I went from f1 to f of x1 to all the way to x6, and then you are going to ask me this question, right? Hey, from 1 to 6, there are 6 numbers, not 5. You want n equals to 5, but you use 6 numbers. I don't care how many numbers you use. I need 5 subintervals. In order to build 5 subintervals, I need 6 numbers. So that's why I have to go from 1 to 6. So take a look at the number lines I built for you. From 1 to 6, I divide that into 5 subintervals. Is the coefficient pattern going to work? I don't think so. Look at the orange number. 1, 4 starts at 1, ends at 1, and then 4, 2, 4, 2. You cannot have another 4. So that's the problem. When the number of subinterval is odd, you cannot have the correct coefficient pattern. But if this is a trapezoidal, so if this is for trapezoid, so let's copy this over. So let's say we have this, and then we copy, and then we paste. What if I want to do trapezoidal? So let's write down for trapezoidal. Maybe I should put the words down. So for trapezoidal, what's the coefficient pattern? the coefficient pattern is you start at 1, you end at 1, and then you put a bunch of 2 in the middle. So when you put a bunch of 2's in the middle, I don't care about the odd or even. All I need to do is fill up the middle with a bunch of 2's, right? But for Simpson, you have to take it a 4, 2, 4, 2, 4, 2, and it must end at 4. So that means the number of subintervals must be even. Alright, so that is the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, share the video for me. Please support to my channel, subscribe to my channel. Appreciate for your help and support. See you all in the next one. Signing off for now.